Today we're on page 9 of the AP Chemistry Chapter 14 packet, and we're going to be determining how to find the pH of a salt solution. So in the last page of the notes, page 8, we determined how to figure out if this salt reacts with water to make it acidic or basic. So the way we did that is to write down HOH underneath it after we realize that this dissolves because of group 1 in this case. Okay, you know it's going to be Na plus and F minus. You're going to look for the acid and base that could be formed from the dissolving. So if you have NaOH, that's going to be a strong base. It does not want to go together. This is going to be HF. It's a weak acid, so it will want to go together. So this is called hydrolysis, as we mentioned in the last video. The F minus is going to react with the water to take the H plus, leaving behind the OH minus, making the solution basic. So we know that this is going to be a basic solution. If you took the pH, it would be higher than 7, and that's what we're hoping to find when we get our final answer. All right, so let's write the equation for what goes on. We discovered that the F minus is going to react with the water. So I'm going to write HOH here so you can see how the H is taken away by the F minus. And you're going to make a HF out of that. AQ, and hydroxide is left over. There's also AQ. Now you're going to do an ice chart. So when you dissolve 0.3 molar NaF, you're going to get 0.3 molar F minus. Of course, you're going to get 0.3 molar Na plus, but we don't really care about that. Then this is going to be a 0, this is going to be a 0. Again, technically this 0 is 10 to the minus 7th, 10 to the minus 7th from water, but it's not going to be significant. So we're going to shift to the right. So minus x plus x plus x. So this is going to be x, this is going to be x, and this is going to be 0.3 minus x. Now you're going to set this equal to a Kb, because this is a base. So you're going to have 0.30 minus x. That's going to equal Kb. The Kb is going to be for fluoride. So fluoride, reacting with water, has a Kb value. However, look at what was given, the Ka of HF. So you're going to have to find the Kb yourself. So remember that Kw divided by Ka will give you Kb for the conjugate base. So let's do the math for that. We're going to have 10 to the minus 14th divided by the Ka given, which was 7.2 times 10 to the minus 4th. And that's going to give you a Kb of 1.4 times 10 to the minus 11th. That's your Kb. So we're going to write that over here. 1.4 times 10 to the minus 11th. And when you go ahead and solve for your x, you're going to find that your x comes out to be 2.0 10 to the minus 6th. And when you have a minus 6, that's definitely not going to affect any of the 0.3 minus x that you had up there. So this is going to be the concentration of the OH minus. Of course, it's the concentration of the HF as well, but we only really care about the OH minus to get the pH from that indirectly. So the negative log of the 2.0 10 to the minus 6th, remember, is going to equal the POH, which is the 5.69, because we took the negative log of the OH. So this is the POH. So if you want the H, you got to do 14 minus 5.69, and that's going to give you a pH value of 8.31, which is basic, which makes sense, because we realize that this solution is basic because the F minus took the H from the water, leaving behind the OH minus, which made the solution basic. Now we're going to move to the next portion of the notes on the next video.